This is my presentation for Lab 4. So the purpose of this lab is to determine the magnetic field dipole made by a bar magnet and measure how distance impacts this value. So the assumptions are that the bar magnet makes a uniform magnetic dipole field, and the magnetic field decreases as distance from the bar increases. The model is in real life model in the lab using the real magnet and the GlowScript Python computational model. And the preview of the results found that the dipole is equal to 22.49 am squared, and n is equal to negative 1.54. So some of the main principles were the Biot-Savart law to calculate the magnetic field made by the electric current, the magnetic dipole formula for a closed electric current, and the distance dependence formula, that fields are weaker the further they are away. So in the model, the system is the bar magnet and the surroundings are everything else, and the procedures were to align the magnetometer perpendicular to Earth's magnetic field, locate the magnetometer chip in the phone, and measure the distances between the bar magnet and the magnetometer on and off the axis. So here's our data. You have the off-axis field and the on-axis field, and this is it plotted. So here's the code. You have the magnitude. This is for the dipole. Then we have the scaling and the code that creates the arrows, creating more of the arrows, and creating the 45-degree angle. And that creates this. You have the values here, the output, the various arrows, and the 45-degree arrow. So some possible errors that could have been caused in this experiment would be from the extraneous magnetic objects present in the room. We had some laptops and phones around. We tried to keep them as far away as possible. And the table had big pieces of metal attached underneath that we couldn't remove. And then there could have just been issues with the sort of janky magnetometer in the phone, but nothing you can do about that. And for the conclusions, what if we'd put the meter stick at an angle between magnetic north? Well, Earth's field would interfere with the bar magnet's field instead of them aligning perfectly, and the results would have been skewed. And what if we had used two identical bar magnets and read the experiment? Well, those two fields would add together, the magnitude would double, but the direction would not change, ultimately. And that's all I have.